the midpoint of segment CA and D is the midpoint of segment CB, then DE is parallel with AB and DE is equal with 1.5 AB. So let's try it. First of all, let me take here a pen. Okay, let me write on this side the statement and here are reasons. 1. Already we see D is a midpoint, so D is a midpoint of CA, segment CA, and E is a midpoint of a segment CB. So this is a given. And now I'm going in the second step. So the second step is DC. We already see here DC is a congruent with AB and CE is a congruent with EB. So in the second step, I'm writing here second step. So let me move here. So second step, already AD is congruent with a DC, and we have here CE is congruent with the EB. This is based on the midpoint definition. And number three, now if we are taking the proportion AD divided by DC, is equal with 1, because AD divided by DC is 1 because AD is with a DC, and AD divided by AD is 1. So same thing we could say here, the side here, CE divided by EB, is going to be 1. And this is based on the simplifying the same item. When we have divided the same item with each other, we get 1. Simplifying the same item, we have 1. Now I'm going here to the fourth, and in the fourth, AD over DC, because both of them are equal with 1, I would say AD divided by DC is equal with CE divided by EB. CE divided by EB. And the fourth here is because it's a transitive property of equality. Number 5. We already see, because the sides of the triangle, the division of the sides of the triangle are proportion, then DE, okay, so DE here, because those sides are we are dividing are proportional, then the DE is parallel with the AB. Okay, so ADE is parallel with the AB. And the fifth one is based on the converse of triangle proportionality theorem. Number 6, if we are looking at those triangles here, angle A and angle CDE are corresponding angles. Based on the corresponding angle theorem, those are congruent, and the angle B is congruent with angle CED based on the corresponding angle theorem. Now, number 6, I would say here the angle CDE is congruent with the angle A, and the angle angle DEC is congruent with the angle B. Okay, this is based on the corresponding angle theorem. Number 7. If you look here, for example, angle C here, both of them, the small triangle and the big triangle here, they share in the angle C. In other words, angle C, number 7, okay, angle C is congruent with angle C. So number 7 is a reflexive property of equality. Number 8. Number 8, I would say the small triangle here. So let me go here. So small triangle CDE is similar to the triangle CAB because of the angle congruence theorem. So in other words, triangle CDE is similar with a triangle CAB. This is based on the angle theorem. Number 9. I would say here, okay, we are looking here the DC, the small triangle, the side of the small triangle DC over DC plus DA is equal with a proportion here because it's similar. Those sides are proportional. So the CE divided by CE plus B are congruent, are equal. In other words, their measurements are equal. And here I would write DC over DC plus AD plus AD, DC plus AD is equal with CE over CE plus EB plus EB. So similar triangles have divided sides proportional. Number 10. Now, because DC is equal with AD and C is equal with AB, we can substitute and we can write a DC over DC plus DC is equal with C divided by CE plus CE. So this is a 10 is a substitution property of equality. Number 11. Because DC here, if we are adding those DC plus DC, we can write here DC over 2DC, because DC plus DC is 2DC, is divided by, I'm sorry, here is a CE, I forgot to write, is a CE divided by 2CE. And if we are simplifying DC by DC, and CE by CE is going to be 1.5. So this is an algebraic operation of simplifying the expression. And number 12, we already see here, number 12, we would say angle D, E over AB is equal with 1.5, because already see the scaling factor of the similar triangles, small triangle and the big triangle, is 1.5. Okay, so the scaling factor, or the dilation scaling factor, is 1.5 for all sides of the triangle. And number 13, the last one here for this, DE is equal with 1 over 2 AB. So is a multiplication property of equality. If we are multiplying both sides by AB, DE is 1.5 AB. See, already proved this statement here. And the other statement is a statement 5. We proved that this one is a DE is a parallel with AB. And what was here? The idea to prove it those two statements. We already proved DE is equal with AB. And the 13th step here, DE is 1.5 AB.